Hello everyone. In the part 1 of the qualitative analysis, we have discussed the introduction of qualitative analysis and primary tests. In the part 2, I have discussed dry test for the positive ion. Now in this part 3, we will discuss dry test for the negative ion. Already I have informed you that these dry tests are new for you. Then after whatever we will discuss from the next part 4, that will be the repetition of the 12th standard. Now see, the first test is a substance plus dilute HCl. If after adding the dilute HCl, colorless gas is evolved with the effervescence, and if you keep your finger or thumb over the mouth of the test tube, then if you can experience the pressure, it is the same pressure which you, whenever you shake any carbonated drink, and the pressure of the carbon dioxide gas is coming from the bottle. If same thing is happen in the test tube, then we can say that the gas is carbon dioxide, and so the ion is carbonate ion CO3 minus 2. In the same test, if you can experience the gas with the bad smell, rotten egg smell, and in that case you should take the starch paper which is available in the laboratory. It is a pure white strip. You have to dip the starch paper into the lead acetate solution. You will find lead acetate solution into the inorganic reagents. Dip the starch paper. So that paper is called a lead acetate paper. Put here, I have shown the test tube. Keep that paper over the mouth of the test tube here. This is not the same figure, but put it here. And the gas coming from the test tube, if turn lead acetate paper silvery black, here you can see that it is a silvery black, then we can say that the gas is coming is H2S gas, and that's why the ion present is a sulfide ion, S minus 2 ion. So these two reagents can be detected with the action of dilute HCl. Next test, substance plus concentrated sulfuric acid, and you have to heat it. Whenever you are using any concentrated acid, all the three, sulfuric, HCl or HNO3, you should work carefully, and you should always use test tube holder. In this test, you can see that there are many observations possible. Colorless gas evolve, mostly indicating presence of chloride ion. Gas is a chlorine. In that case, this is the figure for that. You should take the glass rod, here you can see in the figure, dip the glass rod into the bottle of NH4OH and keep near the mouth of the test tube. Now if the gas coming from the test tube is, if it is a Cl2 gas, and you dip the glass rod into NH4OH, so at their junction point there will be evolution of the NH4Cl, and that's why you will get very white bright fumes. So we can say that Cl minus is confirmed. Another possible observation is, if reddish gas evolve, then it could be bromine gas, and the radical could be bromide, right? Violet gas evolve, indicating negative ion iodide I minus, and reddish yellow gas evolve. That gas is a heavy, normally stay inside the test tube. So that can be NO3 minus. Now see, two observations are there. Here they have written red gas, and here they have written yellow red gas. So almost similar. So what to do? Students may get confused. So there is a test which can distinguish between. Friends, again the starch paper. You should dip the starch paper into the distilled water so it will be wet. Put wet paper. Whenever reddish gas or yellow red gas evolve, you should put or keep wet starch paper over the mouth of the test tube here. And if the gas coming from the test tube turns wet starch paper yellow, as I have shown in the picture, then that gas is a bromine and ion is a bromide. But if wet starch paper stays as it is, doesn't turn yellow, then that ion is NO3 minus. So this is the test you should remember. Many times teachers ask into the Viva, how would you distinguish between Br minus and NO3 minus? So Br minus turns wet starch paper yellow while no impact by the NO3 minus. In this figure, this is purple color I2 gas. See, this is the nitrate. As I said, it is a heavy gas. So not immediately come out from the test tube. And here you can see that Br minus occupy the whole container. This will turn the wet starch paper yellow. This won't. Now third test, repetition of the second only thing. In addition to substance and sulfuric, we are adding MnO2. And same observations. Here it is written that greenish yellow, but mostly chlorine gas is colorless. Reddish brown Br minus. Again, you should check it with the starch paper, and violet gas is indicating I minus. Fourth test is exclusive for the NO3 minus. Substance plus copper foil plus sulfuric acid and yellowish red gas evolve. Then, and no, obviously no effect on starch paper, that we have already discussed. Then it is indicating NO3 minus. And fifth test is for the phosphate radical PO4 minus 3. Substance in the test tube plus concentrated HNO3 plus inorganic reagent ammonium molybdate excess and heat it. And gradually, if you are getting yellow canary precipitate, in Gujarati medium they say the yellow precipitate like the upper layer of the lemon. In that case, PO4 minus 3 is present. Here it is. Here these are the PPTs, precipitates of the phosphate, yellow precipitate, pale yellow. Okay, so these 5 tests are for the dry test for the negative ion. Friends, sometimes this happen that even after performing all the 5 tests, you may not get any negative radical. Yes, this is possible. Always remember that in your salt, there will be one positive ion and one negative ion. Right? Alone positive ion is not possible. So up to this point, if you don't get any negative ion, then there are possibilities of 3 more negative ion. Chromate, CrO4 minus 2, sulfate, SO4 minus 2, and oxide, O minus 2. Okay, fine. So first test. First of all, if your salt, solid salt, is yellow color, then only try to dissolve it into the water, and aqueous solution which you will make, if that is also yellow, then in that yellow solution add HCl, and that yellow solution if turned into orange, then chromate is present. But always remember that if your solid salt, the color of the salt is not yellow, then chromate must be absent. And let me tell you why it turns into orange. Because all chromate salts are yellow and dichromates are orange. Whenever you add HCl, it turns into dichromate. That's why. Fine. Suppose chromate is absent. Then go for this test. Take the substance, add some water. So, you will get aqueous solution of substance. Add barium chloride. And if you get barium chloride is your bench reagent. And if you get white precipitates, then sulfate is present. And if you don't get sulfate also, then always believe that in your salt oxide ion is present. There is no such test for O minus 2. All these ions are absent. It means that O minus 2 is present. So these 5 tests, and if you don't get, then in addition these 3 tests, and you will get the negative ion. So all these tests are called dry test for the negative. They are new for you. One more very important point I want to share with you. Always remember that if your compound is water insoluble, how will you know that? You check the water solubility in primary test. So if the compound settle at the bottom of the test tube, then it is water insoluble. Then always remember that only 4 negative radicals may be present. Which 4? Carbonate, sulfide, phosphate and oxide. But now listen to me carefully, because I am going to tell you very important thing. I am telling you that if your compound is water insoluble, so then only 4 negative radicals are present. It doesn't mean that, it doesn't mean that if your compound is water soluble, so these radicals are absent. It is not that. They can be present, right? So reverse is not true. But if insoluble, then only you will get the negative from these 4 only. So see friends, in the case of negative radical, only perform this test, because carbonate and sulfide, if they present, you can detect from this. Don't perform this test. Instead of performing, just write down it that no observation. So chloride, bromide, I, NO3 minus, etc. may be absent. Let me tell you one more thing. Whether you perform the test or not, but there are certain marks are kept for the systematic representation. So don't perform the test, but you should write it. Next test, even don't perform this one. No need to perform the nitrate, just write down that nitrate, show the nitrate absent. Okay, phosphate you have to check. And if these three are not present, then believe that O minus 2 is present. But again I am repeating that always remember that if it is water soluble, then don't think that these 4 cannot be present. They can be present, right? So in these 3 parts, we discuss introduction and primary test in part 1, dry test positive of in part 2, and dry test of negative part 3. In my next presentation part 4, we will discuss how to prepare solution, because you are given solution ready made and here you have to prepare the solution, and there are a couple of methods of preparing solution, and once the solution is ready, then the remaining part is a repetition of the 12th standard what you did. So I hope that you understand this.